Well, it's time to get serious about soldering surface mount devices, because if I make a small run of these boards, I don't want to have to hand solder every piece on this board with the hot air gun. So what we're going to do is we're going to build what's called a reflow oven, which is basically a device that makes heat at a very specific curve and then cools back down again. And this curve matches the requirements of the solder paste that you put on the board. Now, there are a bunch of reflow ovens for sale on the market, but no, that's too easy. So what I'm going to do is build my own. I got a toaster oven that just arrived, and the heart of it is this Reflow Master Pro from a really good guy in Australia. So let's take a look and see how this is all going to go together. Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. Okay, so let's take a look at what's on the market if I decided not to do this myself. There are a lot of reflow ovens available, and they're really expensive. 2,000 euros, 4,000 euros. They're just all over the place. And, they're meant for companies or, small companies doing small runs themselves, but nothing really practical for the home guy like me, except this style right here. It's called a T962. It'll run 272 euros. And here's the details. It's basically got a drawer that you put your boards in, and you can define your own heating and cooling curve based on the solder paste you're using. But in no way is it as powerful as the unit that I'm going to be using in terms of the definitions, Wi-Fi control, everything else that comes along with it. And I even found a lot of videos for people using this oven. A lot of YouTubers like me, a lot of them show how they're using it. And then down here, this guy, Superhouse TV, he shows how to upgrade the oven with a Reflow Master Pro as the new command and control board for it. So I think I'm on the right direction doing this myself. It's a fun project. So let's dive in. Okay, here is the heart of the system, the Reflow Master Pro, brought to you by the unexpected maker Seon, spelled S-E-O-N in Australia. And this is the web page that describes all the functionality. You can see it's got a color graphical display. It's got a USB-C power input, and there's a little channel in the back of the case where the wires come in and out. He's up to version 3 on the firmware, and I think also about version 3 on the hardware too. It's got a tremendous amount of facilities baked in reflow profiles for the different kinds of solder paste on the market. You can build your own profile. You can have it fire off notifications when different steps are completed. And it has a full website built into it for settings and online performance when it's actually baking in. Now here's the hardware. This is showing version 2025-02, but I got version 2024-01-02, I think. And the only difference is my main controller chip. This is a discrete ESP32 chip. Mine is the metal module that goes on here, like a W Room or a W Rover. And also this 5-volt pin has been moved over here. Otherwise, I think it's pretty much identical, so I'm not too worried. So you can see all the inputs and outputs come along here. It's got profiles. I'll scroll through these different things. And he actually provides a 3D model so you can print your own case. cases in two halves and they snap together. You can see that right here. Let's see. He does not supply the solid state relay that you need to manage powering the coils or the heating bar in the oven on and off, although he suggests one, and I got one similar to that. Here he says, what kind of toaster oven do I need? And this is pretty critical. He says you want one that is no more than 18 liters in size and is more than 1300 watts. And the one I got was 16 liters, so that's good, and 1400 watts, so that's good. The critical thing is the unit has to be able to drive the oven to rise the temperature as needed by the profile. If your oven is physically too big or not powerful enough, it will not be able to drive the oven at the temperature profile you need. So let's go down here. These are the fan controllers. I ordered one, and I'm gonna try not to use it on this first attempt of just getting the unit working. Some people put 1 or 2 fans inside, and some people actually line the box with insulation in order to trap more heat inside and manage the temperature profile better. I'm not going to do that from the get-go, and I'm just going to see how it works. Now, this is the wiring diagram. It looks pretty straightforward with the fans and the temperature sensors, but this is a little odd. This is the solid state relay, which gets controlled by these 2 pins on the board. The solid state relay is like a mechanical relay, but it's able to handle much more power. A mechanical relay, unless you want to go into what's called a contactor, mechanical relay can literally weld the 2 tabs together, and it will then be in a constant on state, which you do not want. So he's recommending one of these solid state relays with a big honking transistor inside this case. Now the odd thing is, this is not a correct description of how to wire the oven, because the oven is not getting power from the wall. It's only basically the power wire. When you rewire it, the wire comes out and then back in again, but nothing from the wall is injecting AC power into this circuit. What you would expect is your AC power is over here. One of the wires comes into this terminal, and when the relay is energized, power goes out to the microwave, and then the output wire of the microwave connects to the other wire of the AC power. So this switch essentially is in series somewhere in the AC circuit, and it's just odd that he doesn't describe it that way. But let me go ahead and take the oven apart, and we'll see what we've got, and we'll figure out how to go from there. Now, from an ordering standpoint, you can order directly from his shop or on something called Tindie or something called Lectrons, which is a European outlet, and this one automatically calculates tax for Europeans. So let me switch over to the ordering page, and I'll show you how that looks. And here's the ordering page. The base unit is $89 US, which is an absolute bargain for the effort he put into this and the components and the assembly. An absolute bargain. He will sell you a case if you want. If you don't want it and you can 3D print your own, just select no. And you can have an order with 1 or 2 fan controllers. So I ordered one, and it cost me a total of $97. And I was happy to send my order off, and we'll see how it looks inside and when I wire it up. All right, here we are inside the oven, and it's about as cheap and straightforward as you can imagine. The metal just bends. That's about as thin as you could possibly get away with. But let's check this out. We've got 3 controls. This is a timer. This is a mode control that says only heat from the bottom, only heat from the top, or heat both. And this is a thermostat control. So the way power flow works is it comes in here, goes into the LED and the timer. And the LED will light up when the timer's on. But it only flows power when the mode switch is on, bottom, top, or both. And only when the thermostat is set and the bimetallic strip here says it is not hot enough yet. So when the thermostat has not triggered, power will flow. And on the other side of these bars, they're just connected in series in the back. So basically what this means is these do nothing. I disconnect these wires and I put the solid state relay in series with the blue and the brown and run that into the control board. So let's do that. Okay, I got the 3D printed case trimmed up with the X-Acto knife, put the unit inside, snapped it together, and it actually powers up with the expected errors. Then becomes, how do you wire it? Now you have to run the wires through the back of the case and screw them into the top. But so here are the thermocouples. But I got to run power through this thing too to get to the solid state relay. Now the question is, where do I put the solid state relay? I'd love to be able to put it right there, right inside where power flows and I can bring the control cable in. But this has got a 120 degrees Celsius over temperature circuit where it's going to cut off. And I can't have that anywhere near where we're going to have 230 degrees running into the solder paste potentially. So I can't do that there. That means it's got to be outside the box. If I put it outside the box, I will have live AC power on these metal terminals, which is not good in the industry. That's known as a not good thing. So what would be great if this went inside the case somehow? The control signals would just jump to it. The AC power could come in and then straight back out again. But the provided case design does not allow for that. There is not anywhere near enough room to put that inside. So what I think I'm going to do is rejig the 3D case to add more space in the back in order to mount this inside. I just don't see another possibility except putting this in another plastic project box and having that like sit behind here. That would be the only other possibility. And then I got to run wires to that. So let me think about that for a little while and see what I decide on. Okay, I was hunting around for ideas about how I can put the solid state relay and the controller in the same enclosure, and I found this one on Maker World by Aaron. He's got one that he designed that actually screws to the front of the cabinet, which sounds good to me. It's close by the unit, it's attached to it, but it's protected from the heat because it's outside. Now, he's only got one picture of this, so I downloaded the parts, and let me bring up how that looks in my slicer. So this is the front, which looks normal, has the 4 holes on this side and the opening on that side. But the back side of it has this attachment point where you screw through the front case and into these holes. And this hole provides a way to get all your cabling in and out to the control board without anything going to the outside. Now, the only thing I would need to change in my overall plan is I wouldn't put the USB power here because that could get in the way of the door opening just to the left. I would put a 5-volt DC power supply inside the unit and run 5 volts to the board and attach it on that strip, just like the others. Now, unfortunately, this doesn't have the capacity inside that I need for the solid state relay, but he does provide a 3D mesh file, which is downloadable. You can download the 3D mesh file,
which Fusion 360 can turn into a solid file, which I can then edit. And I can expand the size a little bit, big enough to put the solid state relay in there, and then I'll upload it as a version of his board and contribute that back to the community. So that's my plan. We'll see how that all turns out.
Okay, after a lot of Fusion 360 and printing, I'm starting from Sion's original case, and I took Aaron's updated case. The front I left alone and printed normally, and the back I extended it by 35 millimeters and kept everything else in place. And you can see it actually fits together quite well. But the only problem is if I tighten the screw at the bottom, there's nothing holding the top together. So what I'm going to do is put 2 small screws along the top and be done with it. And the front, the Reflow Master fits in quite nicely, and the space for the solid state relay goes right there, and everything is encapsulated, minus a couple of screws. So it's all looking good. I'm going to start wiring it now. So in order to power up the controller board, I need 5 volts somewhere inside. So I sacrificed a cheap little 5 volt 1 amp wall wart, and this is what it looks like inside. DC out, AC in through these 2 pins, and I need an enclosure to make it safe. So I did a quick design. There it is. And it slips right in. The LED goes there. This little grommet thing goes there. The AC will come in this side, and then the top snaps on. Makes it nice and safe. And it's funny, I asked ChatGPT if it could design this box for me based on the measurements and where I needed the holes and everything. And it said, I can't make it for you, but I can give you a Python script that you can run inside Fusion 360. And after describing it in great detail, and it reflected back all the main points that it gave me, it kept giving me Python scripts with syntax errors that had something to do with the filleting and making the corners smoother. So I said, okay, forget the filleting, just give me the box. And this is what it gave me. I mean, it's not even close. So lucky for us, the CAD robots are not going to start their uprising today. So let me get this wired up, and then we'll continue on the next stage of the installation. All right, it's mounted in the case. The LED's on. We're pushing out 5 volts. Okay, I've got the control box mounted here. You won't believe this. I'll show you in a sec. I put it where the temperature control used to be because I don't need that anymore. But I do want the ability to set the mode, top, bottom, or both. And I want to be able to use the timer as a fail-safe in case, it just keeps going for hours. I want to make sure that I can set it for, 3 minutes or something like that, a little bit more than the normal cycle time. Now, let's take a look at this. Look through here. See the hole? It absolutely lined up perfectly with both the through hole and all 4 screws. I can't believe how perfect this is. I'm thinking that the original creator had an oven with the same components or something, or maybe this is a standardized footprint for, this kind of thing in consumer appliances. But that is awesome. I didn't put a screw in the top because on this side, you can see it's not actually a perfect hole. It starts to expose itself in the big hole, and I didn't want the chance of wires rubbing against the screw, which is then connected to the frame, which is connected to ground. So this is very robust. So I'm happy with that.
So now we can start wiring.
Okay, everything is wired here, everything is wired here, and the display is ready to go. So let's plug it in and see what happens. Oh, it powered up. All right, let me put it in the box and we'll see what happens after that when we really start playing with fire. Plugged in. Power on. Now I'm going to turn on the timer and set it to both connections, both burners, and we're going to reflow with some default configuration. Start. All right. Let me see what's happening here. Oh yeah. It's already warming up. You can see this is the target and this is what it's at. So let me keep that closed. Focus. I guess the green is supposed to match the purple curve. Yeah, it's getting really hot. And of course there's no insulation, so we're losing a lot of heat. Well, we're behind the purple curve. Let me try and zoom in a little bit. My focus is terrible here. There, that's better. The green curve, oh, green curve starting to come up. But I think it definitely needs a longer warm-up time down in this region. But it seems functional. That means everything is wired right. The solid state relay is working. My 5-volt power supply is working. Everything in here is wired correctly. Well, it's coming up the curve. That is pretty great. Well, that's the smoke test, people. Functionally, it's working great. Plus or minus sticking to the curve, and I'll just read up a little bit on the board documentation to find out how that goes, and I'll get the curve recipe for the solder I happen to have. So let's wrap that up, and then the next one will be actually testing a board. Abort. Before we wrap up, I'd like to thank my Patreons and YouTube members, Peter Bouvier, Puppy, and Craig, for their ongoing support. I see that a whopping 96% of my viewers are not subscribers, so please go ahead and click that subscribe button because it really helps out the YouTube algorithm. Thanks and take care, and I'll see you in the next video.